So this is my blog post, and I'll just share the link with you. Yeah, I suppose. Let me take this away. Yeah. Okay. Yeah. So you can read about that. I'll just briefly summarize. So the one of the things about, so you have already done unit test. Probably you're familiar with that. And my main objection to unit test is, while it's valuable, unit test is a little bit more geared towards an implementation of a function. So let's just say you have written a complex function, and then you can write some sort of unit test or against a portion of your program, and that actually usually tests the implementation. And the challenge is that when the implementation changes, then you have to go back and refactor your tests. And by experience, I witnessed that many times. People don't do that, and then your people just trash away those tests, or just it becomes a little bit difficult to maintain. BDD in the opposite sense, it actually doesn't target the implementation, but it targets the behavior. And one of the objectives is that, and a side benefit, actually perhaps the main benefit, is that think about a spec for your project. So someone has written a Word document where you have the requirements, you're happy, but then almost always the requirements change on the way. And then someone needs to go and update those documents. Well, it may be feasible when you do it on the fly for the first month of the project, for example, first sprints. But let's think about it. And a year later, someone comes up and asks you to change the behavior of something. Then people, I mean, usually the tendency is that those documents become a little bit idle, they're outdated. So behavior-driven development aims, the development process is purely spec-driven, so that your documentation, your code, your tests are all aligned, and they're targeting the target behavior and what your project is supposed to do. So in this blog post, it first talks about a concept called ubiquitous language, which is an important part. It's actually a very common term in domain-driven design, where ubiquitous language refers to a concept where there are certain words, such as when we call a user, a customer, everyone understands the same thing, be it a DBA, be it a developer, be it an IT support or PM, product managers. So it's about building a terminology that we are on the same page. And to build such a terminology, one of the recommendations is to go through a phase whenever you are assigned to a new project, for example, or could be a later as well, a phase called discovery phase, where you are actually discovering what is possible. Because almost always no software project comes with concrete definitions. There are some certain objectives you want to deliver, but also, I mean, by my experience, a lot of things are actually a little bit more vague, uncertain. And the discovery phase is just tries to clarify what you can do, what else you can add, what are the concrete boundaries. And one of the most popular aspects, or just ways, techniques that allows you to do discovery, which aligns with behavior-driven development, is called event storming. In event storming, if you Google it out, you will see there's some people gather, a set of people gather, and then there's a whiteboard, and then they just put stickers, and then and they start with posting posts related to events first, and then they just come back towards the commands and other things. And this approach is very much aligned with behavior-driven development. Though for a certain technique, I mean, in order to apply it to our code, we also utilize usually a certain syntax called Gherkin syntax. And Gherkin syntax says that, well, you can see the example here, that there's a feature, and there's a scenario name. So you have something, you need to implement some feature, you need to talk about a scenario. And the scenario typically starts with, given an initial state, when some action happens, then there should be some assertion about the final state and perhaps an optional assertion about what event inspired. And this comes into play with the event storming. Now let's think about you're supposed to make a project with food delivery, okay? Like Zomato, or I don't know, Uber Foods, or this kind of things, whichever is available in your country. Eventually, the software is not the actual goal, right? What we want is the user to get the food. In that sense, let me ask you a question. How do you start such a project? What is the objective? So we should start from the final objective. And in that sense, there is a final event we can talk about. Could you imagine what that final event would be? What could it be? We are developing a food delivery application. What is the ultimate objective of this thing?
Delivery.
The delivery. So we want the delivery to happen. So probably the event would be the food delivered. If we could achieve this event, even by not using software, but via telepathy, right? If people, you just could talk to the cooks without using computers, and then everything we work with telepathy, that would also work fine. We don't need computers, we don't need software. So that what I'm trying to tell is that software is just a means of vehicle. Since we are not creatures that can do telepathy, we need to pass structured data, and we use a software, and then this software just communicates the intent. But the ultimate objective, it doesn't change. And that's why event storming advocates starting with events, and in particular the last event. Once you start with the last event, such as the food delivered, then you start to come backwards, right? What happens before? Then perhaps you can say the courier arrived. What happens before? The courier started. What happens before? Food is cooked. What happened before? Order is received, right? What happened, or something like order is confirmed, order is rejected. So a group of people that gather in a room and they just storm these events. And then you end up with a lot of set of events. And this is a very good starting point of discovery. That way, it gives you an advantage, a certain advantage, that you just don't miss what is possible. Okay, you always think two sides. So something can succeed and something can fail, for example, right? As I say, order, for example, there is not enough items in the stock. You can reject order, or the payment rejected, or payment accepted. So this kind of things. Eventually, this syntax is actually, in some sense, is similar to typical in the classical unit tests. There's an act, arrange, and assert, AAA, 3A. Maybe you're familiar with that. So it is somewhat similar with that. We just arrange a first state, and then we act via some action, and then we assert. But it's slightly more structured. So we end up with this some sort of state, and then some action happens. We end up in another state, and then subsequently a side event might also be published. A more concrete example of this would be, let's say you are developing a software for an ATM where you money withdraw. So as a customer, I would like to withdraw money from a bank account, or it could be an online banking stuff, I don't know. So one of the scenarios is that, for example, whenever you try to withdraw less than balance, right? Then the scenario is described as, given I have $1,000 in my bank, when I withdraw $300, then the withdrawal is successful, right? Because I'm withdrawing less than the balance, and my final balance should be 700. Whereas the counter scenario is that when I try to overdraft, then when I try to withdraw 1,300, then it just says that then the withdrawal is failed. And as a sense of it, you end up with this kind of specifications, scenarios, which is a plain text. This is not software, just plain text. And then you also do, it allows you to do some sort of event discovery, in general discovery. And you discover like verbs, nouns. Essentially, it allows you to discover your domain. Now, the part I'm going to describe you is that once you have these text files, how are you going to incorporate into your code? How are you going to write tests with that so that they become a real part of your source code, not just text files on the fly that is waiting to be idle? So that's the objective of this talk. Any questions? Yeah. Okay. So that this is done. We have with this blog, and I'll give you a URL if I can find the global. And this is the repo. You can clone it right now, or you can just watch. So it's, or just clone later. It's entirely up to you. I just posted to the chat. I hope this is the correct one. Yeah. So if you open it, in particular, let me just go back. This exists in my case here. Yeah. So suppose that you manage to clone here via git clone. I'm not just. I think you can look at this, the outcomes here, the repo, the URL is here. You can just use it directly if you have .NET 8. In my case, I use a little bit more constrained environment, Docker for desktop. But so if you don't have it, you can just watch it. Otherwise, you can try. It doesn't require Docker for desktop. I have to tell you, but it set up things once you have it for you. So once I open this thing, in my case, it says it's reopening container. But if you, as I said, if you don't have it, that's also fine. What you need to do manually, well, if you're in Windows, well, you can just, there's something called post build sh here. So you can just try to execute these commands in the command line. That should also work. Okay. So this was some sort of project I was playing with it, and I'm going to show it through an example how this thing works. So in order to start this project, I just call, it's a project with a lot of projects, but don't be scared. We are only going to touch a small portion of it. And well, it starts on this 15, 17. Port. Once you end up here, you end up with some sort of this kind of screen. And what this thing is, that's just what the objective of this project is that, well, it actually, there are some sort of events that's going to happen in a particular country, and then it allows you to subscribe to a particular country. In order to subscribe, you need to sign in. You click sign in this thing, and you click Google, and then you can pick one or two flags here. So that's all about it. And then it's actually subscribes you. Okay. So we're going to show that how would you write a few simple BDD tasks against this, and then we're going to see how we are going to automate it to a degree. So one of the first things is that I do is, in the source project, I created a features folder. Let me try to zoom so that it's a little more clear appearance. Yeah, I think this is better. This is my own way, but you can do it other ways as well. And these are just plain text files. So, and I named this as with .feature thing, prefix, source suffix extension. And for example, this spec just states that, well, as an authentication, and it says that, well, there's a sign-in scenario, right? And given I'm not authenticated yet, when I sign in, then I should be signed in, right? And then vice versa. So when I'm signed in, given I'm signed in, when I sign out, then I should be signed out. Well, this is very, very contrived and very simple. Let's look at the subscribe feature, a little bit more sophisticated. It says that given I'm not authenticated, when I try to select the region, then the system should require me to log in. And so a subscription feature, given I'm authenticated, and I'm not subscribed to a region, when I try to select a region, then I should be able to subscribe to that region. And similarly, we have the unsubscribe scenario. So we try to write this kind of text files and we incorporate into our project as the first step. And this just builds up the initial specification. The next thing we do is how we're going to utilize it. So with this, once this files exist, you can write tests different ways. You can, for example, write automation tests, or you can write other kind of tests as well. You can reuse these files as text files. It's not necessarily to be associated with automation tests. And in our case, we'll start with the automation ones. An automation test, if you're not familiar, so let me just also ask this. Has anyone used things like Selenium, Playwrite, Puppeteer? Anyone has used? Not familiar? So before jumping into that, let's just talk about briefly an automation. And what is it about? So this is specific for browser applications. You have seen a browser application. So what I'm going to tell you is not going to work. There are frameworks for them as well, for desktop clients. But their objective is that, how would you, so I click few buttons and things. How would I make the browser to do programmatically, to behave like that? And once I have done that, it's like an end-to-end test, right? I can make, because I don't want after every change, I don't want to open the browser and do this manually. Maybe there are hundreds of features, and I want to instead maybe integrate this to my CI/CD, and then it should do it automatically every time it's changed. For that, in the old times, the most popular framework was called Selenium, which is still probably widely popular. But recently, more, I would say perhaps modern frameworks came out. One of them was Puppeteer, which is from Google. But then a group from Puppeteer has joined Microsoft, and they just came up with the Playwright. And Puppeteer and Playwright is they are very similar. But perhaps the primary difference is that Puppeteer is strictly testing on Chrome, whereas Playwright is a little bit more geared towards supporting different browsers. And another difference is that Puppeteer is only JavaScript, so it works on Node, whereas Playwright, it has a support for, it's primarily also a Node framework, but it's support for .NET, which is what we are going to use today. So if we go to this Playwright dev, you can see the docs. So it talks about the installation, writing tests. For example, this is plain C#, and what we are going to use isn't very different. And let me post the link. And for example, it says that, well, go to this page and make sure that the page has a title with this containing Playwright. And then, well, get a link whose name is get started. So it gets the link. And then it makes sure that this says an href attribute to docs intro. And then the next thing is just click that link And then once that link is clicked, we are expecting another heading available called installation. Okay, it will be visible, for example. In particular, this syntax, they just opt in, which is also I prefer, by roles instead of directly using CSS or DOM, because it gives you a little bit more flexibility. They approach the page a little more semantically. But you can also use plain old CSS selectors. That also would work. And there's a lot of details, which is way out of our scope, where you can do a lot of different levels of automations. But it is good. It's a good framework if you want to automate the browser. Okay, so this is what we are going to cover first. We are going to see how we can incorporate our BDD tests into the Playwrite ones. Essentially, it will replay those scenarios. Any questions? Unclear parts? All good? Okay. So yeah, one of the things, if you look at this post build sh, if you use a Docker container, it will execute for you. Otherwise, you can execute by yourself. Is that it needs to install a set of browsers. In particular, in the Docker environment, which we don't have a UI, it's like a very virtual machine, Linux kind of thing, right? We can't even see the browser at all because it will run on headless mode. And these two scripts would install all the browser and relevant dependencies into your machine. Okay, so that's a PowerShell script actually. And that's pretty much it. So let's just see how let's first run the automation test and then see how it is written. In my case, I like to use packet and fake. This is a fake script. So if you're not familiar with fake, I just tell you, fake is like it's a build automation script with F#, where it allows you to run certain targets, certain scenarios. It's not very popular or endorsed. And I have dedicated videos in my YouTube channel. You can see there's a lengthy video describing how to use packet and fake. Yeah, and we can just see where it is mentioned here. We have a target called run automation, and this is what we are going to run. And what it essentially does is it runs this .NET run under this test.automation folder. That's what it does. Okay, essentially. Let's just run it. Hopefully it will run fine. Then you'll see what it does and how it works and how we incorporate BDD into that. So it's running, and actually it's actually running the actual browser inside the virtual machines. So you don't see the browser because it's running on a headless mode, which means that there's no visuals, but it literally runs the entire ASP.NET, starts a browser, clicks the buttons, and then does the assertions. It already done all of these things. So it's very valuable. And you can do this kind of things in your CI/CD environment whenever a change happens. This brings us another framework, which I talked about, Playwrite, before moving into the code, called TickSpec. So probably in .NET, as far as I know earlier, there are many different BDD frameworks. And perhaps the most popular one is SpecFlow. Has anyone heard of it? SpecFlow, maybe. But I kind of like BDD with TickSpec. The reason is that it's less on direct code generation. It generates IL code with reflection emit. It's a little bit more hardcore, low-level stuff, but it doesn't get in the way, and it's a little bit more manual. So let's just see its page, and then let's go through its simple examples. And now let me post a link. Suppose that you have this kind of text file, okay? And luckily, F# is a language where you could just use, as long as you use this backticks, you can just use the same syntax. Notice there's a line here called given a customer buys a black jumper. So with TickSpec, what you do is to correspond that item, you just use this given attribute, and then you just write the same text in backticks. Similarly, the next thing is saying, and I have 3 black jumpers and left in stock. Now, the and here means actually we would like to repeat what's previously written, which is in the given. So in the code perspective, that will also be given. And that's why it's not and, because there's no such thing actually on the code side. It's given because it just and means just repeat the previous one. Okay. And now you see something peculiar. There's something like a dot star here, which is obviously a regex statement. I mean, regex expression. Well, it's a regex. And then what you do is you just write the entire thing, but whenever there's a parameter you would like to change, like 3 or 4, maybe for another scenario you want to write 4, you just use regex. And TickSpec is smart enough to figure out that, and then it will give you that number and assign it to here. Okay. And notice when this code runs, the variable with n, the parameter with n will be 3, because it will parse this thing out and it will capture 3 because it just corresponds to this part, and then it will assign it to here, and it will just change the stock item. Similarly, the when statement is the action we take, and then which is the corresponding part, and the then statement is again there's a regex here which captures the final statement, and then we just mix our assertion. But that's all about it. Once you provide this text and once you provide the code, and we'll see how we're going to stitch these things together. When you run TickSpec, it is able to parse this thing and execute these functions in the correct order. And that's essentially how you map the spec into your code. And this spec file is something you would share with your PMs and product managers, but they reside in your source code. And that's how you keep your documentation, your specs up to date. You never get outdated, because if your spec is outdated, then it means that your code is outdated. That somewhat is a gentle enforcement for you to keep the spec, code, and everyone is on the same page aligned. Any questions? Any confusions? Curiosity? Anything? Any part? All good? Okay. So, well, the thing is, the slightly annoying part with regards to this is that you see that there's a mutable variable. This is perfectly fine, by the way, but it's less idiomatic, right? Because in F# we like functional programming. We don't like mutable variables, and in particular, this might be a problem if you run the same test over and over again. So we don't want one of the tests results or just affect the other test. Okay, so there's a slightly better way, which I prefer, to not to use mutable variables. In this case, this is our state, and which is affected by, you see that each line of function just alters this stock item thing. But can we do without mutation? Can we go without mutation? The answer is yes. So instead, we create a stock item, a record, for example. And then what we do here, instead of mutating the stock item, we create an instance of it from scratch, as if it never existed. And once you return this variable, this object or record from your function, TickSpec is smart enough to pick it up and will store it somewhere in its own storage. And then next time, whenever another function needs same type, it will inject that state into that function. So once we return this count n, in this it will be 3, that record will come here as an input. And notice in this case, we are updating the count as 4, right? And then this will return the same thing with 4. And then it will come here with what value? What value will it be? What's the count? 3, 4, 5. Any answers?
Less.
Why one less?
How many did he buy?
So let's just start over. Because the text says that we have the 3 here. The 3 will come here. It will come here. So initially it will be 3. Yeah. And this will be returned from here. What will come here? This is the second line. It will be S3 again, right? Because this is just what we returned from the previous function. And then here what we do is we increment the 3 to 4. And then we are returning again, which replaces the older instance. And then here it will come as what number? It will be 4.
4.
Yes, because that's what we are returning from here. So essentially, we are replacing this item. Once you follow this methodology, then you can see we can get away without using any mutable variable. It's like a parameter injection. We never mutated anything. And this ensures that your tests are isolated and they don't pollute the global state. Oh, cool. I like it. And you can see also it is not an F# specific framework, although C# lacks of this kind of backtick syntax. Actually, all you'd have to do is just use an attribute and then just use the plain syntax. It's not bad, actually. So you can just use the same thing with the same syntax. I'm not sure. Well, in this case, you can just use a class, and probably you might not need to worry about mutables, right? Because in this case, this is a module level variable, and this is a little bit concerned. Okay. Here's another feature. Well, in your text file, you can just create a table, for example, just like that, using these pipelines, and then it will just generate a table, and then it will give it to you. But then you can extract the data. Okay. And you can, for example, create lists. Which in this case, in the actors, and then you will get a list of actors. So that's the essence of BDD, and it has a lot of different examples here. And with TickSpec, you can see the examples here. The tricky part, which is the good side and the bad side, I'm not sure if you like it, is that many frameworks come with a very easy way to wire up many other frameworks. But TickSpec actually wants you to do it manually. I like it because I have a lot of more control. It's less magic, but it might be a little bit daunting if you're doing the first time. You might get confused how to do it properly. Luckily, now you have a working example, which is my repo. You can also see that. So that's the essence of TickSpec. Now let's see how I apply Playwrite, TickSpec, and all of these things. Let's just see how they come together. Okay. So one of the things is, as you would remember, I told you, we have these feature files. It's just a plain text file in my source folder. And one of the good techniques is that actually we're going to utilize is that we are going to use them as an embedded resource, which is actually an artifact from the old .NET framework times, but it's still valid, if you remember. But what we do is very simple, so don't be afraid of when you hear this term. All you have to do is whatever feature file you're interested in your project folder, you just add it as an embedded resource, and that's all you need to do, just one liner. So since I use a VS Code, I don't use any tool. I just copy paste this line and that works. So if you use like a JetBrains or Visual Studio, I think you can still do the same, but also they may offer other alternatives how you would embed these feature files. Once the feature file is embedded, it's like a text file is put into the assembly DLL file, which you can extract it as a stream. Okay, that becomes actually part of your DLL, not a separate file. But after the compilation succeeds. So let's see what references this project has. So this project has 3 NuGet packages. One is extra core, the other is TickSpec, and the other is Playwrite. They're 3 primary. So you don't need anything else to proceed. And just like any good .NET application, we have an enter point. This is the main function. That's where we start. And I open the TickSpec namespace. I say, well, give me the current assembly name. And then this TickSpec function constructor gets you the definitions. The definitions is these functions, actually. Okay. And then I say, well, from this assembly, I would like to get these embedded resources. Because the assembly name is starting with automation, those files, so it will be a subscribe and authenticate, will be prefixed by automation. This is standard way of doing it. So basically say that automation.subscribe.feature, I would like to get that file as a stream. And once you get the stream, you just call definitions.execute and you pass the stream. And then that's it. So this is the stitching part. It will find all of these functions, parse this text file, and call those things one by one. And for both of these subscribe and authenticate files. Any confusion here? It will find these resources, that embedded resources, okay, each of which. And this definitions already knows about those functions, which I will show. I haven't shown you yet. And it will execute them one by one. So I expect these tests to play. That's the essence of it. So let's start with the authenticate. And obviously, well, let's start with the setup actually. So this is my personal way of doing things. You can do it after, it's very opinionated way. You can do it other things. So I just create a configuration file. This is standard ASP.NET stuff. And then I actually call the ASP.NET host. So this is standard ASP.NET host. So you don't need to mind these details, but in some way, if I assume you have some familiarity with ASP.NET, standard ASP.NET, C#, not F# related. And there are many ways. Now we have the minimal syntax, etc. It's a little bit older edition. And it just creates the host. And what I'm doing is just I'm calling this function to start an ASP.NET host, whatever. So I'm not going to talk about these details. Once I have the host available, which is started here, this is again standard ASP.NET, I would like to start a browser so that I can do my automation test. And how I do is that I call this Playwrite create async.result. The reason it's result is that almost all functions in Playwrite are async. But since this is a unit test, there's not much harm to enforce synchronicity. I can call results. It's not going to go deadlock or something like that. Once I have the Playwrite, for example, in this case, I opt in for launching a Chromium browser here. And these instances stay forever for all tests because they're static variables. It's a module level variable. Then Playwrite offers me 2 hooks. One is the before scenario, and the other one is after scenario. The before scenario executes for each scenario. Let's remember what is a scenario, if you don't remember. So each of these texts represent a scenario under a feature. So for each scenario, the setup will reset the environment, reset my variables, etc. And then, well, it will start a new browser context. So the context is like, you can take it like, perhaps it's like you are logged in per user kind of thing. So it has its own cookies. So it's not interfering with other contexts. So each test you will want a different context typically, because you don't want your tests to interfere with each other. And also, I like that if there's anything HTTPS, which is optional, I don't want any HTTPS errors to come up. So I don't mind that. Okay. So this actually gives me a browser context. The next thing happens is that, well, let's go with the given. So this is the first thing it's going to execute. Notice this has to match to this text file. I'm not authenticated. Okay. So it will find the TickSpec will find it out. Will find it out, and we'll inject that context that we have constructed in setup here. We constructed this, right? Because I'm returning that, we'll inject that. And then I'm going to execute these steps. In this case, in my test, this is my test specific. I say, well, clear all cookies, which will make me unsigned because it was a cookie. It was doing cookie-based authentication. Then give me a new page. Then I'd like to go to the following URL and then return this page. Once I return this page, that becomes injectable, just like we have seen in our case. Then the second thing is when I sign in, signing is like, if you remember, I pressed a sign in button at the top of the screen, which I will show you again. But this says that find a button where it has a text called sign in. And click, get the first one if there's multiple, and then click it. Then there should be a dialog shows up. Get that dialog, and then, well, in this case, I can't automate the Google level authentication. I'm just using a different trick. So there's a text field there, and I'm filling that text field with my email address, and then click sign in. Okay, I'm going to demonstrate this, how this happens. So this is the second part. Okay. And the third part is then. It says that then I should be signed in. Which, how do I test it? Well, in this case, I like to test it by, I would like to see there's a button with sign out. Okay. Now you may ask this question, because the browser is a little bit asynchronous environment. You click a button, then it's not instantaneously effective, right? It takes some time, things load, and then just because I signed in doesn't mean that this sign out button instantly appear. It will take time, maybe 100 milliseconds, I don't know. But usually automation frameworks, almost all of them, are smart enough to wait, let's say 30 seconds or something like that. So if this condition doesn't hold, it doesn't immediately fail. It just waits up until some sort of timeout. Tries again, another second later, it tries again, still doesn't hold until it holds, but there's also some sort of time threshold. If it doesn't hold, let's say till 10 seconds, I still don't see this button, and which is configurable, by the way, then it says, well, sorry, your test is failed. Okay. And you can see there's a second test here. So let's see what it does in action again, just to visualize, refresh our memories. Okay, it showed up. In this case, I'll just use this URL just because my testing environment requires. Okay. Well, I should just sign out because I'm not. Okay, let's do that again. Oh, sorry. So it comes here and then finds the first button to sign in. Okay. Then it finds this text area. Sorry. Find my placeholder. So it finds the text area with username and fills it with this text. Then it clicks to the sorry. Yeah, it clicks to here or what? Yeah, sign in test user. So it clicks this one. So it finds the dialog, then it just, you see, it finds the dialog, and then it, I mean, I did it manually. Then it checks that if there's such a text called sign out occurs or not. And that's why the test is passed, actually. When I run it, it passed. It was one of the tests. And that's pretty much it, actually, the essence of it. Yeah. So that's pretty much it. What I want to show you next is briefly is that just this kind of tests aren't specific to automation tests. For example, I have another kind of test, which is non-automation, which is an expecto test. And I'm a big fan of CQRS pattern. Well, I'm not sure if you're familiar with expecto. Expecto is an F# friendly, more function-oriented testing framework. It's somewhat popular in F# community. It's like XUnit, but more functional and composable. But if you're not familiar, that's not a concern. You can just use XUnit as well. Here in this case, you will see a little bit, it's a little bit more tricky because TickSpec doesn't know nothing about an expecto tests. So as I told you that you need to do wiring, and the TickSpec documentation explains some of these things. And in my case, I had to wire this manually, which I'm not going to talk about because it's a little bit more expecto specific. But once that wiring is done, similarly, you can see a feature is implemented here, okay? A global event feature. And then then it's essentially the same thing. It starts the application, but now it doesn't use the browser. It just calls the functions one by one. In this case, our test is called global event feature. So you can see this test say that, well, given today is some date, and I have the following subscribers, which is like a table. And when I publish for the event for Argentina, nothing should happen. And then it's this kind of scenario. So this is a little bit more business logic here. And this set of events is wired up, which is actually not fully implemented, through these things. It's a little bit more complicated scenario. There's sort of rejects and there's some sort of complicated returns. But essentially, my point is, once you end up with these feature files, you can just reuse it for different tests. So you're not limited to automation tests. You can just do any kind of test, and you can use the same file for both automation and non-automation tests as well. It's just a plain text file, and that's pretty much it. I was going to share with you. If you have any questions, or we have time, if you want me to repeat any portion, not any part isn't perfectly clear, I haven't clearly demonstrated, feel free to ask. It's a good time. Otherwise, I will wrap things up.
I have like two questions. One is a technical one, I think. So what happens if you have a step with the same name, but you want to have different, I don't know, functionality inside the definition, I think it's called?
That's a very good question. This is supported by a TickSpec called tags. So in some sense, you can put tags in your file. This is supported by Yarkin. Something like, for example, I don't know, important customer, for example. You want to have different behavior customer, okay? Or let's say, for example, some tests should need to run in holidays in different way. So you decorate with this kind of tags. And then let's just see the documentation here. Maybe it will be more educative. We go to this, so tagged examples. You can also see, for example, here there's a more realistic example is that so this just issues get smoke whatever these tags, and then you can accommodate, which this didn't show, but you can accommodate depending on the tag.
Yeah, it's okay. I was just wondering because this was something.
So you can accommodate based on this tag. It's a supported scenario. You can just call one of the things in one scenario. I think, if I'm not mistaken, even there was an attribute which allows you to put tags here, which I have done this before a few times. Let me just see on top of my head if I could just figure it out for you.
No, it's okay. I can read the documentation. Thank you.
Yeah.
The
second.
Another question is there some way to pretty print the results to get the list of what features have passed or at what steps they have failed? Because
I think that's also a good question. Though we can see the output, but I think it is, well, there's a lot of logging here.
Yeah. So now I'm using Expecto to run some. Actually, it's integration test, and it has like a list summary or something, but it's just the individual test. And if I try to write something like a feature, I have to write it all in a single test name, and it's not pretty, but it's workable, I think.
Let's see. On top of that, I think what you say it's a fairly important feature, but I just can't recall if it's for. As far as I know, I don't recall. But let's just see. I just run the test, and then are we able to see anything related to? I'm waiting for it to finish up. Yeah, there's a lot of application level logs. So I don't recall such a feature, but I think what you say is it would have been nice if it's supported.
I think there should be something like that, but I will read the documentation.
Yeah.
So I didn't know about TickSpec. I only knew about SpecFlow, and it's not. I couldn't really make it work with F# and Expecto, and it's. So
I used SpecFlow a lot earlier. I think something like 6-7 years ago. It was nice, but it relied on a lot of reflection and code generation, and that part I didn't like. It's so yeah.
Yeah. So yeah, this is a really good starting point. I'm gonna look at the Alarms Global project. I'm gonna copy a lot of it, especially the Expecto part. So thank you very much for showing us. And
thank you for listening. Yeah. Anything from Stefan? Anything from you?
Not at the moment. I will take a close look at your repo and but that was fantastic.
I will post this to YouTube. Probably then you can watch it. And then if you have any questions, I presume you can contact me via Twitter. You found me there, or from the meetup group. You can also send me a message either way. So I'll just try to answer your questions. Thank you for joining. I wish you a good weekend.
Thank you very much.
Thank you.
Have a nice weekend.
Yeah.
Bye bye.
Bye bye.